All right, now that we know about the basic gates, we're going to start looking at how do we create truth tables from larger circuits. All right, so let's start off. Let me erase some items here. And we're going to examine this circuit right here. Okay, in order to get this circuit, we need to kind of figure out what the expression will be. So we have an AND gate. I'm going to put the little dot in there. And then I have an OR gate, so I'll put the little plus sign. And we need to figure out what the expression is for Z. So we're going to do this starting from the left, and as we move over, we're going to fill in what the expression will be. All right, so we have B. B enters a NOT gate. So right after that NOT gate, that symbol now is B bar. Then I have an AND gate. A and B bar enter the AND gate. So that would generate that I have an A dot B bar. And to make things a little bit more cleaner, I'm just going to take out the dot. So let me take that out, and I just say it's A, B bar. Make sure when you're writing out these expressions, you only have the bar over the letter that needs to be negated. Then last, we get out the A, B bar with C into an OR gate. So we can say Z is equal to A, B bar plus C. All right, so we have that expression. Now we're going to figure out how we fill in a truth table. All right, so I'm going to use the color coding so we can set up our truth table. So on the left side, we're going to have our inputs. Our inputs are A and B. I only have two inputs. That's four options, 0, 1, 2, and 3. So I got 0, 0, 0, 1, 1, 0, 1, 1. And I'm going to fill out each piece of this circuit one part at a time. All right, so I have B bar. How do I find B bar? To find B bar, I'm only going to look at B. So I'm going to look at B is a 0. What value should B bar be? It's going to be the opposite. So it's going to be a 1. Next, it's a 1. It should be a 0. A 0 should be a 1. And a 1 should be a 0. Okay, so you're going to identify which piece you need to examine. All right, let's move over to our term in blue, which is A, B bar. All right, so to determine A and B bar, I'm going to look at A, and I'm going to look at this new term I made, a B, B bar. Okay, so in AND gate, remember we need both items to be a 1. So here are two items where A is a 1. Here we have two items where B is a 1. It's only going to be when both are 1, which is the case on the third line. Every other case would be a 0. All right, so we identify A, B bar. All right, last item is we got this Z term. Oh, I made a mistake. We got to put in a C. Let's do this. Let's erase C here. And let's have C be a B. All right. So we got A, B bar plus B. So what terms am I going to look at? I'm going to look at A, B bar. Then I'm going to look at B. As long as one of them is a 1, this result would be a 1. So I got 0 and a 0, that's a 0. A 1 and a 0, that's a 1. A 0 and a 1, that's a 1. And then a 1 and a 0, that would be a 1. That's how we go about, creating this truth table. Here I did all these intermediate terms so that it helps us build out how to fill up a truth table. In most cases, you're only going to put in A, B, and Z. You would not need to put all these intermediate terms. I say do the intermediate terms as you are starting. So as you start, you can start learning how to create these logic statements. All right, so let's do something a little bit different now. Let's make it a little bit more complex. Now I have a number of gates. First gate is A and B going into an AND gate. So in red, I'm getting this AB. Below it, I have C and D going to an AND gate. So in blue, I got CD. Then CD goes through a NOT gate. So I put CD and I put a bar over the entire item because I'm knotting the entire segment. So when you draw out these items, CD with a bar over it, that's different than C with a bar over it and D with a bar over it. So they're not the same. If it helps you, if you get a little confused, you can do CD and put them in brackets, and you can say I have a bar over the bracket. So however it is that you want to denote where you're knotting. And then the last item is we have A and B in red with C, D bar in green going through the NOT gate. And then in pink, we are getting AB plus CD. Okay, so we're going to fill out the truth table. We have 4 inputs, A, B, C, D. So I'm going to create the truth table with A, B, C, D. Again, I'm going to number them 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way down till we get to 15. I wrote the values at the bottom because as I scroll, we're going to lose track of what column we're in. And then I have in red AB, I have in blue CD, green CD bar, and then in pink AB plus CD bar. All right, so let's find these one at a time. All right, so let's work on the red. I'm looking at AB. So I'm looking at AB. I'm going to identify where they have both ones. So we keep going down this list. We see we have 4 0 0. So those are zeros. Then we have 4 0 1s. That would be a 0. Then we have 4 1 0. So again, we have zeros. And then finally, we get to 1 1s. So for those 4 cases, AB would be a 1. All right, so we found AB. Now let's find CD. We're going to do it the same way. We're going to look at CD and see where both cases are 1 1 0 0. That would give me an output of 0. 0 1 is 0. 1 0 0. Here I have a 1 1. So that 1 1 that produced the output of 1. We keep following 0 0 0. Again, I have a 1 1. So that would be a 1. A 0, a 0, a 0, 1 1. Then a 0, a 0, a 0, and a 1 1. All right, so that's how we find CD. Next, I got to find CD bar. How do I find CD bar? I'm looking at CD. And then I'm going to take the opposite of it. So if it was a 0, I take a 1, a 0, take a 1, 0, take a 1. 1 is a 0, 1, 1, 1, 0. 1, 1, 1, a 0, a 1, 1, 1, and a 0. That's how we find CD bar. In the pink, now I am looking at AB and CD, and I want to do an OR. So this OR, as long as one of them is a 1, I'm going to get an output. So I got a 0 and a 1, that's a 1. Here in green, we have a 1, green's a 1, so we have 3 1s. Next case is 0 0, so that's a 0. Then I got 3 1s for green. Then I go down to the next one, it's 0 0, 3 1s. So as long as I know I have 1 1, I know that the output is a 1. Next case is 0 0. And then I have all 1s on AB, so the last 4 are also a 1. So that would help you, on trying to figure out how to make a truth table for a circuit that we have. All right, so I want you to try out one on your own. So here you're going to have AB going into an AND gate. So what would that be? That's AB. Then I have a C, bar, because that's a NOT gate. Then that gives you C bar and a D from that AND gate. I got an OR gate. That OR gate would be A, B plus C. And then I got a final OR gate, which would be A, B plus C bar D. So you're going to want to go and create a truth table. Remember, you're going to put A, B, C, D. You're going to do 0, 1, 2, 3, all the way till you get to 15. And then you're going to find out each of these values. You're going to find out what AB is, what C bar is, what C bar D is, what AB plus C is, and then the final A plus B plus C bar D bar. All right, to help you along, I say create the truth table, and then I'm going to show you a way that you can verify it. The way we're going to verify it is we're going to use a website called circuitverse.org, and then you can use this to kind of test on how your application is going to work. So let me get the website up, and then we can follow through and show you how to use it. All right, so if you go to circuitverse.org, you'll come up with this website. And we're going to do the button that says the launch simulator. So we're going to launch the simulator. And you're going to have this area with the grid where you can draw out your gates. If you want to save your projects, you can go to project. I think the best option is probably to save offline. That way you know where you don't have to make an account and you know where your files are going to be on your own computer. All right, so we have inputs. So the inputs you can use are, you can use this item here that's input. So you click it and you can drag it over. Now, if you scroll down a bit, you're going to see properties. And we want to give this input a name. So let's give it A. So you see like a little A pop up after it. All right, so let's do 3 inputs. So let's do A. I want to change that to be B. And then let's do another one of C. Okay, so we have 3 inputs. If you want, you can go over here and zoom in a bit. To move around. Okay, then let's get a gate. So we'll go down to gates. Let's do a couple of gates. Let's do an AND gate. Let's do a NOT gate. And then let's do an OR gate. So there's other gates down here. We'll get to them later in our class. So we have a couple of different gates as well. All right, so now we're going to want to draw the connections. Okay, so to draw the connections, you're going to click on the dots, draw out. You can stop and make new lines in. So you're going to make A and B. Let's have those connect into this AND gate. Let's have C go to this OR gate. And let's have C go into this OR gate, and then AND go into the OR gate. And then we'll have an output. Okay, so let's go to outputs. To make things line up, you have options. You can use LEDs or you can use this little output box. So we put this output box, we can connect it there. So it will evaluate. I think I'm having trouble with the, okay. So it evaluates automatically. So how are we getting a 1? Well, we get 0. That's producing a C bar, which would be a 1, and a 1 going into an OR gate would generate a 1. So if we change C to a 1, we just click on it, and then we see we get a 0. So these brighter green light lines, those show that you have a value of a 1. So you see whenever it's connected to a 1, you see that it lights up. So you can go and you can test your truth table to see if you got everything correct. If you wanted to make things a little neater, you have this little text box. You can put the text box down. So then you can say, I want it to be, I'm having trouble typing in here. We want it to be C bar. If you need something that's bigger than a 2-input gate, I'll show you how to make that. So let's say I wanted a 3-input AND gate. Okay, so I drop down this AND gate, and I'm going to go down to properties, and on input size, I can increase that to 3, and you can see that you get 3 little dots for your inputs to have connections. All right, so this can be useful that you can, verify your results. So take that problem, make it as a truth table, and then throw it into Circuitverse to see if your results of the truth table matches by you clicking and changing each value. All right, so next time we're going to look at trying to take our expression and start looking at simplifying it.